Okay, can someone give me an example of a rational number? Any number that's rational? 1, okay. What else is a rational number? Okay, 7. 1 plus 7, okay, 5 plus 2/3, okay. So if I add two rational numbers together, I want to know if the resulting answer is rational still or irrational. So remember, rational is a fraction, okay? It's a decimal that ends or has a pattern, okay? So if I do 1 plus 7, I get 8, right? Is that still rational?
Yes.
Good. Because it's still a decimal that ends, okay? Now, if I do 5 plus 2/3, okay? 5 plus 2/3. You guys see that okay? Wait for it. There it is. Is that decimal end or have a pattern? Yeah. Okay, so what that means, do you guys know what the little bar on top of a number means?
Unlimited. Infinite.
Infinite, goes forever. Good, okay. So did you make sure you put today's date on it, right? Yeah, just so my TA doesn't get confused since it's not with the group. Okay, so on this one, what happens when we add two rational numbers together? It stays rational. Okay, what's an example of a rational number? Another one. 4, okay. Now give me an example of an irrational number.
-2.
Oh, that's still rational. Pi. Pi's.
-3.
So those are integers. Those are still rational. So pi or square root of 2. Remember, irrational are the ones, the decimals go forever. And so with no pattern, so we have to give them a symbol, okay? Thank you. So this is a rational number plus an irrational number. So I want to know if when I add those together, is it going to become rational or irrational?
Becomes irrational.
Irrational, good. So I just did 4 plus pi.
Where's pi at?
So on mine, it's above the caret sign, but it might be in a different spot on yours. Usually it's one of the ones you have to press the second or the shift button. It's probably not its own button. It's probably like on the top left. Here, bring me your calculator real quick, Josh, and I can show you if you can't see it.
I said 7.14E0.
Oh, yeah, yours is just in a weird mode. I'll fix that.
Yeah, you broke it last time.
4 plus pi. There you go.
Oh.
Okay. Two irrational numbers. How about pi plus the square root of 2? Remember, irrational. Decimals that go forever with no pattern. Okay? So they usually have to have a symbol. So if I was going to add the square root of 2 plus pi, my guess, do we guess that it's going to still be a decimal that goes forever with no pattern? Or is it going to all of a sudden have a pattern? Still no pattern. Good. So it's irrational. Yeah, both of them. Questions? Okay, so let's do a couple examples really quick. Okay, on number 5. Is the square root of 36 rational or irrational? Careful. You have to simplify it. So it's rational. Oh, we use Q for rational. If it helps, put P is irrational. Q is rational. Okay? So this one is a rational plus another fraction, rational. So is my answer going to be rational or irrational?
Irrational?
So let's look back up here. What happens on number 1 when I add 2 rational numbers? Stays rational. Good. So, rational. Well, some of these questions are...
We don't have to actually solve it. We can do QQ if you go rational.
Yeah, all I want to know is if the actual answer is going to be rational or irrational.
Show.
Yeah, you don't have to. Now on 8, it's stupid because it's the same thing. So change this to be the square root of 10. Okay. So this one is a fraction plus an irrational. So is my resulting answer Q or P?
QP.
Nope. So I have a rational plus an irrational.
Oh, wait, P.
So that fits into this one up here. What happens when we add a rational plus an irrational? Irrational. Good.
So it's P.
So it's P or irrational. That's most of our lesson today is just figuring out when I add or multiply different types of numbers, what type of a number am I going to get out?
Yes.
Okay. Questions? Can we try some more? We don't actually have to simplify them. All I'm using is from up here. I know that anytime I add 2 rational numbers together, then I know my answer is going to still be rational. So you just have to know what number type the number fits into to know what type of an answer I'm going to get out. I don't care what the answer is. I just want to know what type of answer. Jasmine, does that make sense?
What type?
Yeah. It might help to have your Venn diagrams out while we go through this that have all the different number sets. Remember we did that on the very first day? Might help to have that out.
Does that mean every irrational number is imaginary? Or no?
No. We haven't talked anything about imaginary yet.
I was curious.
Yeah, you're good. Okay. Let's go back and do the product ones. Okay, so go to number 3. If I have 2 rational numbers, okay, so rational, remember, means fractions or decimals that end or have a pattern. Okay, so an example of a rational number, maybe 4/3 times, how about -1/2? Okay, so those are 2 fractions being multiplied together. Right? So this is a Q times a Q, a rational times a rational. Okay? So I want to know, is my resulting answer going to be rational or irrational?
Rational.
That's our guess.
That's my guess.
Well, I think it's a good guess.
Oh, so you got it wrong?
No, you got it right.
So it's rational?
Yeah, so look, if I take a fraction times another fraction, my answer is going to have a pattern, so it's another fraction. You guys with me?
Yeah.
Yeah? Okay, so then my answer is going to be rational. Okay, let's try another one. If I do 1/2, so rational, and then I times that by an irrational, how about square root of 3? So this is a Q times a P. Is my answer going to be, I'd like you guys to be trying these on your calculators as I go through them. Okay, so we think the decimal is going to go forever with no pattern. Wait for it.
Was that right?
Yep.
I don't remember the last time I was wrong.
I wasn't here last time.
Okay, one more. What happens when we multiply 2 irrational numbers together? So let's try it. Square root of 5 times pi. What do you think?
Wait.
you guys see the calculator okay? Okay, so irrational?
Yeah.
Okay. But I got a problem.
What is it?
Here's my problem. Is the square root of 5 an irrational number?
No.
Yeah.
It is. Yeah. So if I do the square root of 5 times the square root of 5, isn't that the same thing? An irrational times an irrational, a p times a p, right? Well, the problem is when I multiply those together, that decimal doesn't go forever, right? So this one, it depends, right?
So it's rational.
Well, this one is. So this one, okay, it depends. So what does it depend on?
What's in the square root?
What's in the square root? If it's the same thing, if it's the same irrational number, then it ends up being that the square roots cancel, okay? So this one, it depends. So if the numbers are totally different, it's going to stay irrational. But if it ends up being the same square root times itself, then it's going to become rational. It's like the square roots cancel. Go ahead.
What do we do pi times pi?
Ooh, good guess. Or not good guess, but good question. Because it's like, is it always if it's the same thing? No. So this is a specific property. It has to be the same square root. So pi times pi is still irrational. So the depending, it only works for square roots. Yeah, great thought, Dawson. Okay, great question. So let's write that one too. So pi times pi is still an irrational number. Good?
Yeah.
Okay, let's try a couple examples. Okay, is square root of 42, use your calculators, okay, is that a P or a Q? Is that a rational times an irrational or what? Number 6 now. So is square root of 42 a P or a Q? Rational or irrational? It's P. That's not a perfect square. Type it in your calculator if you don't know. Okay, what about square root of 9? Okay, so is P times Q an irrational or a rational? Is it a P or a Q?
It's a Q. Wait, yeah, it's a Q.
Well, the square root of 9 is. Okay, so go back in your notes. What's P times Q end up being?
No, it's a P.
Rational.
Irrational, P, good. Okay, is 63 over 9 a Q or a P?
Rational.
Rational, good. So that's a Q. What about square root of 25?
Rational.
Good. So then my answer is going to be what?
Rational.
Good.
Wow.
I know, speedy. Okay, let's just stop here. What questions do you guys have? Anything? 1/3 done with our lesson. You guys are doing great. Okay, if you're having a hard time with this, then the way to get better is to really look at that Venn diagram so you know the different number sets, okay? Now we're going to do real and imaginary properties. Any questions?
No, man.
Okay. Okay, let's go back up and look at number 2.
Oh, wait.
Okay, give me an example of a real number. Did you say pi or 5?
5.
Okay, I was like, well, I guess it doesn't matter. They're both real, huh? Why can't, okay, 5. Oh, hold on.